go. So the test on Thursday, you'll have a section of about 12 vocabulary words. I'll write out a definition, and you have to tell me what that is. Oh, I know what that word is. That word is reactants. That word is coefficients. And I know you haven't been here for 2 weeks, isn't that right? You've been here for 2 weeks, right? But what you would do is you would go home, and this paper that I gave you, you could go over that page right there. There's at least 10 or 11 vocabulary words on that page alone, isn't there? And so you can just review, just look at it and say, oh yeah, I know those words. Remember the word aqueous? What about, you know what AQ means? Oh, I forgot that one. Okay. And those are some words. How about, there's some more vocabulary words. How about double replacement, single replacement? See that? So I think you're going to do well on the vocabulary word section. Just write down a list of words and say, I'm not giving you a word bank, and said, these are the words I should know for this chapter. And you're going to do well in that part. Number 2, I have a part where all you do is classify the reactions. You're very good at classifying. I've watched you on the quiz, you were good. Here, classify. You're very good at that, aren't you? And then the next one's balance, right? Some balancing is easy. Some balancing is hard. And somebody just has to stay with it, don't you? And what's the part we started working on before you left? And I told you that was the last part. It's the higher level part of the chapter. What was the last part we were working on? And that's changing English into Khmeris, isn't that right? So I thought what we'd do here, before I give you back your quiz, let's do did we do these two? Did we do all these or not? And I know you haven't been here for 2 weeks, so let's see what it is that you said, well, I'm glad the test's not till Thursday, but how do you write copper? Okay, now, sulfuric acid. I'm going to have to review that. I may have to review my polyatomic ions. I may have to review that. How do you write sulfuric acid? What's the famous polyatomic ion in sulfuric acid? Sulfate. And how many hydrogens will you need then? Does that seem right? Is that kind of coming back to you a little bit? Okay, yields what? Copper 2 sulfate. Does that work right for you? Okay, plus what? Now, because I don't have hydroxide over here, I'm going to go ahead and keep the water as H2O. Get that? The only time I normally write water as HOH is when I have hydroxide on one side. And what's the other guy? Sulfur what? Okay, now this one I can tell could be a hard one to balance because sulfate didn't stay as sulfate. Okay, so then we balance it. Let's do the next one. How about hydrogen? This is where some of you made a mistake on the quiz. How do you write hydrogen? H2. How do you know? Ooh, diatomic, isn't it? It is. And how do you write nitrogen monoxide? Oh, this was the one on the quiz. Darn. Okay. Yields what? Water and what? This was the one on the quiz, isn't it? Anyway, and then you balance those to those, and that's how we do it. See that? So what I'm going to do is, let me talk about, real quickly, how you can get ready for the exam. I have good and bad news for you. As a 10th grader, my exam, good news, is not till a week from Friday. That's good. What's the bad news? Well, you'd have already had 1, 2, 3, 4 exams before you take mine. You see that? And so if you don't pace yourself during the week, you're going to be kind of tired. And so you got to pace yourself, don't you? When you get done, that's going to be your hardest day, in my opinion, because you're taking 2 different kinds of exams on the same day, aren't you? So that's the one you're going to be a little tired when you get done. So go home and just relax. Do nothing for a couple hours. Then, if you can find 1 other person, 2 other persons, said, hey, come on over. Let's set the clock. 90 minutes. Let's study our old test for 90 minutes. And you'll be done. I'm hoping that this Friday, you should be able to study in this class with groups, in a group, and Monday. Friday and Monday are study days for my exam. You're going to have your old test. You're going to sit and study those, and you know you would have studied at least 2 hours for the exam. You get that? And then you say, okay, but I want to do a little better than I thought. So maybe you form a little study group on that day later on, maybe at night. And then you're done. Everybody see that? I believe you'll probably you're going to get yourself ready for these exams first, aren't you? I have a test on Thursday. That's true. After that, I would concentrate heavily on these. And that's for 2 days in a row, isn't it? And then after you relax a little bit, then you got to watch out for that one, because some of you don't like math. Some of you do like math. And some of you like foreign language, some of you don't like foreign language. Okay. Anyway. All right, I found this. I thought this was worth like $100, so I don't know if how much is that worth? Is it $100? How much is that worth?
One.
Oh.
I mean, like 10 cents.
Yeah. Okay. I'm just kidding. My son gave it to me. I said, "Do you have something that not really worth that much?" How much was it? About 16 cents or something like that? No. How much is it?
Like 10 or 15 cents.
Okay. Oh well. Anyway, you're very good. You're very smart. You know that? You're very smart. Okay. So anyway, what I want to do is, as far as the exam, I have all your old tests back there and a folder. Some of you, before the break, got your tests and put them in there, and some of you didn't. That's fine. But I know if you don't do it by Friday, I'm going to make you do it on Friday. I'm going to make you get your old tests and put them in there, and you're going to sit with people. So if you said to yourself, I'm just going to wait till Friday to do that, that's fine. Now, we're going to take our test on Thursday, and I'm hoping to get it done and graded and give it back to you by Friday. And so that'll be studying for that part of the exam. And then I'll say, now you have the rest of Friday and you have all of Monday to study for my exam, like that. I'm not against you on Monday. If you said, listen, I'm responsible enough, I am going to study for the exam, but is there any way on Monday we could form groups and study for humanities? I'd be willing to let you do that if that's what you wanted to. Or if you said, you know what, if I don't study on Friday and Monday, I probably won't study for exams, chemistry, so I better do that. So you can grow up a little bit and say, I'll make the decision. What do I do? I'm here. I think I can study on Friday and Monday. All right, well, that's that. What I'm going to do is I'm going to hand you back your quizzes. Yes? Yes, I want to hand you back your quizzes and go over those real quickly. You did very well. You actually did very well on them. Some of you did better than others, but nobody got below C. That's good. And we didn't have that many C. Right. So you know everybody's name. Yes.
I told you before break, but I couldn't find my chapter 1 test. Could I get like
I'll look again. I have another stack of papers back there. I may have found them and put them in that stack.
Okay.
Also, very little of chapter 1 will be on there. It's hard to ask questions about a lab, the candle lab. It's hard to do that. So, very few questions will be on chapter 1. All right, everybody ready? I'll tell you what I did. It says there are 3 points apiece, and but I wanted a quiz should be a helping tool, not a punishment. And so I did subtract from 43, and that means that the first one you missed did not count against you. So if you really don't like these ones on the bottom, you say, I got to get better at those. I got to get better at those. Well, even if the first one of those you missed, it didn't count against you. So that's why you had scores over 40. How many people in here, raise your hand if you had a 40 or higher? 40 or higher. 1, 2, 3. Okay. Anyway, we also have some other people that had some other A's. I'll show you the results real quickly. One of them I made a mistake. Wait. This is 4, 5. There, sorry. So we actually, out of 2 classes, they had 6 A's, 4 B's, 3 C's, no D's, no F's. You guys 4 A's, 5 B's, 4 C's, no D's, no F's. So that I thought was a pretty successful quiz. And quizzes should, if you got a C, it probably woke you up a little, should wake you up a little bit. Said I need to start working a little harder. If I got an A, don't be too complacent. Make sure you say I gotta get that A. An A on this next test will help a great deal of you. Some of you have like an 89 average in here right now. You need to get an A on this test, and I know you can. I'm not putting any pressure on you, but in the past, this has been one of the highest average tests. Not because it's easy, it's just because there's only a certain amount of material. So I'm going to encourage you to do really well on Thursday's test. Yes?
Are we going to learn anything new for the test?
Okay, the only thing we're going to do today, I have 5 demonstrations that I'm going to do, and they're going to help you write in Cheminese. And I will have some questions on the demonstrations. But if you're here watching the demonstrations, you should be in good shape. I even have a handout sheet where you just write stuff that I'm doing today. Let's take a look at the quiz. Here's how I graded it. I went over here and graded these at 1 point apiece. So almost all of you got every one of these right. You might have missed one, or most of you missed none over here, okay? Now let's go over here on this side. Again, there's little tricks. Some of them don't have tricks. Here, I don't think you should have made that mistake, because if you put a 7 here, you know on a combustion, on this kind of combustion, you can't put an odd number there. It'll never bounce. You double it, don't you? So I think some of you should remember that trick. I was a little disappointed that everybody doesn't know how to write aluminum oxide, write the formula. And here, I made a mistake myself. I almost didn't reduce that one. So the answer is really 433 on that one. Okay, what do you think about the top first 10? What do you think? What do you want to see? Say, hey, I don't see how you did number 4. Which one, Sawyer?
Let's do number 1.
Okay. Now here's the tricky part, number 1. Okay. This is N1H4, isn't it? It's N1H4. There's no parentheses here. And this is N1O3. So how many N's do you have? How many nitrogens?
2.
How many here? 2.
2.
And how many hydrogens?
4.
So I put a 2 there. That gives me 4 hydrogens. Now watch. 2 times 1, 2 oxygens, plus 1 is 3. And there's 3 right there. So the tough part here was there's nitrogen here and nitrogen here. All right, what's next? Good question. Good question. Yes?
Did you do 11?
Okay. Oh, I'm going to do those. Anybody, first 10. How about the first 10, though? You sure? Yes, Leroy. 8. Let's take a look at 8. Now, what I do here, even though I saw 6 there, and you tend to put a 6 there, I get it. But then, see this 14 hydrogens? It looks like you want to put a 7 there, but on a combustion reaction, putting an odd number from that water, not going to balance. So what do you do with this odd number 7? What was the trick I showed you before? To double it. Once you put a 14 here, how many hydrogens do you have? Everybody? 28. So I need to put a 2 here to get 28, don't I? But how many carbons does that give you?
12.
Okay, now watch. 12 times 2 is 24 oxygens. 14 times 1 is 14, or a total of how many? Total of 38 oxygens. What times 2 is 38? 19. Okay. What else? First 10. Yes. First 10. All right, let's get to the ones that you didn't do so well on, okay? If you need to review your polyatomic ions, you may have to do that, okay? Maybe you need to look at your rules on how to name acids. Maybe you need to do that. But here, aluminum oxide, aluminum's +3, isn't it? Isn't that right? And oxygen is -2, and so that's why you have to have that. Carbon monoxide, isn't that it? and then we have aluminum and carbon dioxide. I thought the tricky part here was trying to find the number. This is like trial and error, isn't it? This is a tricky one. How many of you got this one right? I thought a couple of you did. Okay. You just have to fight with it a little bit, don't you? And so by putting a 3 here, that gave me 3 oxygens plus 3 more. That gave me 6 oxygens, and that gave me 6 oxygens here. So that was a little tricky one. So next. What about, why did some of you forget that the diatomic elements? Remember the diatomic elements? See, if you'd written H2 here and N2, I think you would have found, you could have balanced it. So, anyway, what else? Is that what you're asking about? How to do it? You're asking about number 11?
Yeah.
Okay, I did that one. I'll do it again. So we had 2 aluminums, 3 oxygens plus 3 more. That's 6. There's 6 and 3 carbons, 3 carbons. So I don't have a trick for that one. It's just, you have to try different things there. But the only equations that usually have big numbers are combustion, and even some of the combustions have low numbers. But I usually are not going to get too high. If I get up to like 16 on one of these, I probably did something wrong. So, all right, what do you think? All right, so what we're going to do is I'm going to give you a handout sheet, and I'm going to do some demonstrations. And what you're going to do is get in the habit of trying to see, can I write this out in Khmer? Can I write English things in well, there, right. Behind you. Can you get those sheets for me, please? And if you give everybody one of those. All right, so here you asked me about new stuff. What we're doing is, it's not necessarily new, but we're going to balance equations. We're going to write some equations out and balance them. And I think you'll enjoy this. I'll save some of the better ones till last, because today we have a shortened day. And so I'll save some of the better ones tomorrow, okay? All right. You know, when you write down things on paper, that doesn't mean it's a real chemical reaction. An equation represents a reaction, but what is it that people want to know throughout history? They want to know, why when I put these two together, a reaction takes place, but when I do these two, another reaction doesn't take place. Why? And so they came up with a series of different things. They're called driving forces. What is it that tends to make a reaction take place? Why do the things on the left side of the equation want to become the things on the right? All right, the first one I want to show you is that when you see a color change, not always, but most of the time, it represents some kind of a chemical change took place. Now, that's not the driving force, but it's evidence that something might have happened. So I'm going to show you something. Start right here. And I'll show you under a white and a black background. It's very difficult to see, but what I'm going to do is start with some sodium hydroxide. Do you know how to write sodium hydroxide? How do you write sodium hydroxide? I know you haven't been here for 2 weeks. I know that. What do you think? Sodium hydroxide. Yes. Yes.
NaOH.
Yes. NH plus 1. OH is minus 1. Okay. So we have NaOH. That's right here. And by the way, this is called a base. A base is a metal hydroxide. Most often it's type, group 1. Group 1, like lithium hydroxide, sodium hydroxide, potassium hydroxide. Calcium hydroxide is also a base. But anyway, your group 1 and 2 metal hydroxides will be the opposite of an acid, will be called a base. Okay, now what does this look like? It looks like water, doesn't it? It didn't look like anything. Everybody got that? Looks like water. Okay, now I have another material. I have some hydrochloric acid. How do you write hydrochloric acid? Everybody remember how to do that? Laura, do you remember that? Hydrochloric acid. Yes, very good. And look, what does hydrochloric acid look like? Looks like water, doesn't it? Now, if I put those together, it'd be very boring. it'll look like water when I get done. But we did this at the beginning of the year. I have a chemical which is going to help me. It's going to tell me if something's going on. What do you call this group of chemicals that actually indicates that something happens here? What are they called? You use BTB, litmus paper, something that indicates, what are they called? Indicators. All right, now, take a look. This is called phenolphthalein. It looks like water. Now watch what happens. When I put phenolphthalein in a base, I'm going to use a white background here. Look at that. They both look like water. But if I put the phenolphthalein in the base, it'll turn it like a magenta pink color, isn't it? What do you think happens when I put it in an acid? Nothing. So on your handout sheet, it says underneath there, by the way, that might be a great extra credit question for the next test. How do you spell phenolphthalein? Very difficult to spell. What do you think? Phenol. You know how to spell it?
I think so.
Okay, without looking? All right, Phenol.
I'll have to write it down first.
Okay, good. It's very hard. It like breaks too many rules. Phenol.
Yeah. T-H-I?
So it's weird because it's Phenol, right?
Mm-hmm.
Then it goes PH, then TH. Isn't that weird? Phthalein. And then you got it. Then you think you're done, and it's AL. And then a lot of English words are IEN, but not this one. What's this one? EIN. Okay. Anyway. Now, what I want to show you here is I'm going to let these react. What happens when I put an acid in a base? If I didn't have the phenolphthalein, you'd say, that's boring. It looked like nothing happened. But take a look. I'm going to put a little bit of acid in here, and watch what happens. Now, if there's more base than acid, it'll stay pink. But what happened when I put the acid in there, it reacted, and then it became, there was a little bit more acid than there was base. See that? And that's when it turned clear. Right now, that thing must be a little bit more acid than base. You see that? Now, I don't know how much base I have left, but just to show you that the indicator was not destroyed. Oops, darn it, I'm gonna run out. This is really concentrated. I may run out. Oh no, no, dang it. The acid was really, really concentrated. Come on. You're right, there, see that? Now, there's actually a little bit more base than acid there, see that? And so I want to show you, and by the way, I bet maybe one drop might even do it. Let's try that. Oh, I spilled it. Look at that. Okay. All right, here we go. Let's see if we can write this in chemistry language. All right, ready? Oh, I got water on it. Okay, ready? HCl. Now, what does AQ mean after that? Dissolved in water. Aqueous means dissolved in water. Got that? And NaOH was also dissolved in water. And what if I tell you that's double replacement? What would you put on the other side without looking? What do you think would happen if I tell you it's double replacement? Anybody?
Water and sodium chloride.
All right, so HOH, which is water. And what's the other one?
Sodium chloride?
Okay. Now, if you remember, looking at the beaker, though, I don't see any salt. Where's the salt at?
Dissolved.
Yes. So what do I put after NaCl? AQ. And then this is liquid water here. Now, what was the driving force? What is it that scientists think caused this reaction to take place? It's whenever two things react and they produce, it's called the formation of water. When water is one of the products, it tends to make the reaction take place. So the driving force was the formation of water. Okay, and don't forget that phenolphthalein in an acid is clear. If it's pH neutral, it's clear. The only time phenolphthalein changes is when it's in a base situation, okay? You guys ever heard about the word pH? Ever heard that word? Okay, so pH is a scale that goes from 0 to 14, and 7 is neutral, right in the middle, and A comes before B. Your acid pH numbers are low numbers. Your base pH numbers are high numbers. You get that? Have you ever done anything with pH?
In like a pool.
Okay, so things that taste sour or tingle your tongue a little bit, they're probably acids. Vinegar, orange juice. What else did you tend to put in your mouth? A lot of the stuff has vinegar in it, like taco sauce, ketchup, mustard, pickles. Those are all vinegar. They all have acetic acid in them. Now, if it tastes bitter or it feels slippery, it's probably a base. And that means the pH would be above 7. That would be like soap. Pure chocolate is, I think, a base. I think I have to look that one up. Okay, let's do the next one. I'm going to skip that one till tomorrow. So let me turn this over. And what we're going to do is, I'll get some more equipment out here. And I need to put my goggles. I'm going to put my goggles on. Even though this is kind of a safe one, I still want to put the goggles on. All right. So what I'm going to do here is I'm going to do a black background so you can see a little bit better. And we're going to do number 4. So everybody go to number 4 on the back page of this one. All right, I have some stuff called silver nitrate aqueous. See if you can write that down. How do you write silver nitrate aqueous? Even though I wrote it for you. Everybody got that? Let's take a look, see what it looks like. What does silver nitrate aqueous look like? What's it look like? Water, okay. And what we're going to do is, I have another solution called calcium chloride aqueous. How do you write calcium chloride? But calcium's +2, and chlorine's -1. Okay, now, let me show you what that looks like. What does CaCl2 aqueous look like? What's it look like? Water. Okay, so now, let's put them together. What do you think is going to happen when I put them together? Now, I didn't give an indicator, so how am I supposed to know something's going to happen? Let's take a look and see what happens. Can you see that? Now, I don't know if you understand what that is, but that's a solid. Little tiny pieces of solid. Oops. Little tiny pieces of solid are coming together. I know the light's reflecting off that a little bit, but let me shake it a little bit. See a little piece of solid? Okay, so let's take a look at the, how do you write this chemical reaction? All right, it's double replacement. So what are you going to put over here? What's going to happen if it's double replacement? What do you think? Double replacement. Silver what? Watch now. All right, silver what? Uh-oh. Oh, tell me one of the products here. I know you guys haven't been here for 2 weeks, but what do you think? Silver chloride. How do you write silver chloride? Silver's +1. Chlorine is -1. What's the other product?
Calcium nitrate.
Calcium what?
Nitrate.
Nitrate. Calcium's +2. Nitrate is -1. Everybody get that? Now we go ahead and balance it. I actually did this for the other class, but now you go ahead and get 2 nitrates here, only 1 nitrate here, so you put a 2 there. That's 2 silvers, 2 silvers. Okay. What do you think? You okay on that? Yes.
How do you know which one is going to make a solid?
Excellent question. Now, it would not be fair to you to bring that into play now because your test is on Thursday. Get that? But the next chapter, I will show you a little tool. It's a chart, like up there. And you can look both of these up. And it'll tell you that one of them is soluble in water. and this guy is. So you'll never see the calcium nitrate because the chart, and for this test, you will not have to know that. That's an excellent, insightful question. You did a great job. If you look this up on the chart, next chapter, you'll find out it is not dissolved in water. You know what happens when it doesn't dissolve in water? You see it. And that's silver chloride. Silver chloride is one of the most famous of all the chemical precipitates, and it's a white precipitate called silver chloride. Yes?
Can't you put silver nitrate on wounds?
Okay.
Is that a thing?
How do you know about silver nitrate?
Well, I've seen people get it after they've been.
You can look up silver nitrate. You'll see that in the past, people have been putting it on different things. Wounds. At one time, I think they even had it as an eye drop. I would not recommend that.
No.
But I believe that if I looked up the history of silver nitrate, you would find that it does several things.
I think it helps scab faster.
I'd have to look that up.
Yeah.
But I do know that silver nitrate, honestly, has been used in the past, and it successfully. Okay, great question. You guys are good. I love this. All right, any questions on that? Let's do one more for today, and then one more. Ready? A solution of lead 2 nitrate reacts with a solution of sodium iodide. I want you to write that down. I know you haven't been here for 2 weeks, but just push yourself a little bit and say, how do I write that? How do I write lead 2 nitrate? Everybody okay so far? Look, lead 2. I mean, you can look in the periodic table. The only thing that you look at CPB. But lead 2 means you put a +2 there. Nitrate's a -1. We got to fix that, don't we? Everybody okay on that? All right, see if you can write the other one. Sodium iodide. What do you think? What's the charge on iodine? So I think we're done with that one, all right. Now, this is also a double replacement reaction, so what's going to happen over here? Yes, but and by the way, in first year chemistry, I'm not going to change lead. If it starts out at lead 2, it's going to be lead 2. Lead 2 iodide. Now, how do you write that? Something's wrong here. See that? What's the other product? Sodium. Oh, I like that. Look at that. +1, -1. Let's balance. Ready? 2 nitrates. 1 nitrate. 2 sodiums. 2 sodiums. 2 iodines. 2 iodines. All right, here we go. 30 seconds. We'll be done. Here we go. Here we are. What does lead 2 nitrate look like? Aqueous. Water. What does sodium iodide look like? By the way, you're going to do an experiment later in the year with this. And what happens when I put them together? Watch it now. Watch it. Be careful. Watch it. Woohoo! Look at that one. All right. And next chapter, I'll show you how do you know which one of those is the solid, okay? It's this one, but you don't have to know that for this chapter. All right, well, welcome back, and I know you have to kind of push yourself a little bit for the next week or so, but you're going to have a break after that, another break. Yeah, silver nitrate, I know that they, I believe they use it in babies' eyes at one time. It prevented, there was something, I'm going to look that up because about 20 years ago I read that, but I have to look that up. But yeah, so I didn't know you would even know about silver nitrate. And also in photography, there's a lot of silver products used in developing photography.
I've only seen it used on like games and stuff.
Yeah.
Like it creates like a crust.
Where did you buy it?
I didn't. I've just seen it.
Okay. I wonder where you buy it. I've never seen it in a CVS. I've never seen it there. I'd be interested if they sell it there.
I think it's one of the things that you just like have to get if it's something really bad.
You can
go to the
order?
hospital.
Okay. I wonder if a doctor has to. I don't know. All right, bye, Dave. Hey, I'll tell you what. I'll give you extra credit if you can look up the use of any other health uses of silver nitrate.
Yeah. Okay.
I'd love to read that article.
Yeah. Thank you.
Yeah.
Kickball! Time to play some more retro ball. Good. I need to get $4. I need $4. 1 week of retro ball. Otherwise, I don't get this defensive lineman I need. So I have. I don't get $4 this week. Trade me. Go around. My money died. That's defensive lineman. I need it. I need $4.
Oops.